All right, here we go. Reading data B. Number one, so we have a scatter plot here. It says a curator at a wildlife society created a scatter plot to examine the relationship between the gestation period and life expectancy of 10 animals. So gestation's here at the bottom, life expectancy's over here on the side. What is the life expectancy? So they're wanting to know this value over here in years of the animal that had the longest gestation period. So out of all these animals, the one with the longest gestation period is this dot right there, all right, which would be at 60. And the life expectancy, it looks like, would be 3. So the correct answer here is A. All right, number 2, using the same graph of the labeled points, so just the ones with letters, which represents the animal for which the ratio, so remember a ratio is a fraction, of the life expectancy to gestation period is the greatest. So we want the biggest number when you do life expectancy over gestation. All right, so let's kind of look at these. So if we focus on A, the ratio for A, life expectancy is 7, and gestation is roughly 22. So that's the ratio for A. And as we go over, it just kind of gets smaller because when you look at B, that's going to be 8. So top number is a little bit bigger, but the bottom number is much larger, looking like 43. So that's quite a bit smaller fraction. C and D, really not much better. C would be, 8 over 52. D would be 10 over 52. So all of those are smaller. It looks like A is going to be the biggest one. All right, moving over here to number 3, renewable energy consumption. Make this a tad smaller so we can see it all. It says the bar graph shows renewable energy, 2000, 2010. So we kind of have to focus right up here. That the dark blackish gray there is 2000, the lighter 2010. In a scatter plot where renewable energy in the year 2000 is plotted along the x-axis, so they're saying if consumption is plotted along the x-axis, and that's for 2000, and then 2010 is plotted along the y-axis. So for instance, if they made a different graph and they had all the 2000 numbers here on the x-axis, then they did all the 2010s over here on the y, how many points would be above the line y equals x? So this line y equals x is basically the 45-degree line, and we're just trying to figure out, the easiest way, any dot that's above that line means that the 2010 number is going to be larger than the 2000 number. So if we go through here, how many of the data points? So it looks like for biofuels, 2010 is larger, so there's one. Geothermal, 2010 is larger, so there's another one. Hydroelectric is not one, okay, because 2010 is smaller, so that dot would be below the line somewhere. Wind is larger, and wood, so there's wind, and wood is not. So it looks like we have a grand total of 3, so the correct answer there is C. Kind of an awkward question. Number 4, using the same graph, of the following, which best approximate the percent decrease? So the percent change. So first of all, remember the formula for that. It's going to be the change divided by the original amount. That's how you find the percent change. And we're looking at wood power from 2000 to 2010. All right, so we go up to our graph. Let's focus on wood power. So in 2010, it looks like wood power was right at 2. All right. And then we go, and this is in quadrillion BTUs is the units. And then in 2010, or I take that back, 2000 is right here, which would be 2.25. And then 2010 is at 2. So we have 2.25, and then 2010 is at 2 even. So the amount of change is 0.25, so that's this top number. And then the original, what it was originally, was 2.25. And so when I divide those two out, it's going to be a little bit smaller than 1/10, so about 1/9 it looks like. So correct answer here is 11%, B. If you divide those out, you'll get 0.11 roughly. All right, moving on to number 5. The number of 3D movies released by year. According to the line graph above, between which two consecutive years? All right, so that's back to back. We want the greatest change. So looks like the biggest change to me on this graph is right there, this portion. And that goes from 2000 to 2011. So the correct answer there is D. Nothing too tough on that one. Number 6, looks like we have a chart here. Trees and growth factor. One method of calculating the approximate age is to multiply the diameter by a constant called the growth factor. So it looks like to find the age, you multiply the diameter times the growth factor. All right, and they give us growth factors right here. According to the information in the table, what is the age? So we don't know this. What is the age of an American elm with a diameter of 12 inches? So the diameter is 12. The growth factor of the elm is right here. So that's 4. So 12 times 4 looks like 48 years old. So the correct answer there is D. Moving on up to number 7. And we need to use the graph from, I don't believe that's number 5. I think there's a typo there. That should be from number 6, which is our chart over here. So let's see what the problem asks. It says, according to the information in the table, what is the age of the elm with a diameter of 12? That's the same question. So when you're entering this on your submission form, number 7, hopefully you're putting the same answer as you did for number 6. All right, number 8, also from this graph. If a white birch and a pin oak each now have a diameter of 1 foot, which of the following will be closest to the difference in the diameter 10 years from now? All right, so this one is a little bit trickier. I'm going to go back and erase this off the table just so that we have a kind of a clean spot to work with here. So let's see what we need. We're talking about a white birch and we're talking about a pin oak. So we have white birch and then we have the pin oak. And remember some key features we need. We need age, we need the diameter, and we need the growth factor. We don't know their age right now, but it says each now have a diameter of 1 foot. So remember the diameter, it said, had to be in inches. So we know the diameter is 12. We know the growth factor for the white birch is 5.0. So it looks like our white birch right now is about 60 years old. The pin oak, if it has 12-inch diameter and its growth factor is 3, well, that's going to give me an age of 36. So this is now, all right, because it said now. So now let's focus on it. The question says, which of the following will be the closest to the difference? So we're going to be subtracting in inches their diameters 10 years from now. So I'm going to redo this chart 10 years from now. So the white birch 10 years from now is going to be 70 years old. And we don't know its diameter. Call that X. But we do know its growth factor is 5. So to solve for X, you divide both sides by 5. And it looks like X, or I guess I could have called it D. It looks like the diameter of the white birch is 14. So I'm going to write that over here. White birch is 14. Now, if we do the 10 years from now for the pin oak, it's going to be 46. And we don't know the diameter. And we do know the growth factor. And if I divide 46 by 3, that gives me a diameter of, what's that, 15 1/3? So the pin oak is now going to be 15 1/3, or 15.33 repeating. So final question wanted to say, it said, what is the difference in inches of the diameter? So it looks like I can go back over here. I can subtract these two, and it looks like 1.33 inches would be the difference. So the correct answer there is C. Pretty tough question. There was a lot going on that one. All right, moving up here to number 9. Let me kind of do my eraser and get rid of some of this stuff here. Just kind of get all that. Kind of learning this new software. All right, it says sunflower height of tree over time. Over which of the following time periods is the average growth rate the least? So, you know, I'm kind of looking through all these graphs here. We're going. Well, it looks like it's the least up here at the top, but I got to look at my choices. So A says 0 to 21. Well, 0 to 21, that grew quite a bit. That grew 60 inches from 0 to 60. So from 21 to 42, you know, if I wanted to, I could also use the chart. So from 21 to 42, well, that grew, you know, over 100. 42 to 63 would be from here to here. So 169 to 47, you're looking at about, I don't know, roughly 77. And then part D, days 63 to 84. So 63 to 84, that's not much at all. That's only a growth of about 7. So we wanted to know the least. So the correct answer here is D. Keep on going. Number 10, distance and density of planetoids. We have distance here on the x-axis, density over here on the y-axis. Scatter plot. According to the scatter plot, which of the following statements is true about the relationship between the average distance from the sun and its density? Well, it looks to me right now like we have a negative correlation coming down, meaning that the farther away you are from the sun, or the greater the distance you are from the sun, the less your density is. So let's kind of go through the answers. Part A, planetoids that are more distant from the sun tend to have lesser densities. I think it's that. Let's just go through. Planetoids that are more distant from the sun have greater. No. The density of a planetoid that is twice as far from the sun is half the density. I might have to check that numbers. Part D, the distance from planetoid to the sun is unrelated. Well, there's definitely a relationship here. So let's look at C. The density is twice as far from the sun is half. The density of a planetoid twice as far from the sun is half the other one. Well, let's find 2 and let's compare them. So if one is 2 away from the sun, that has so the distance is 2, and that has a density of, it looks like it'd be 3.75. Well, then if we go half that distance, if we go here to 1, which would be right up there, that'd be distance of 1. A distance of 1 is going to be at 4.75. So it does not look like it's half like they said it was going to be. So C is out. Correct answer is A. All right, number 11. Teresa's running speed and time. It says Teresa ran on a treadmill for 30 minutes. Her time and speed are shown above. According to the graph, which of the following is not true? So be careful there. You do have this word not true. So 3 are going to be right. 1 of them is going to be wrong. So A, Teresa ran a constant speed for 5 minutes. Well, on the chart, a constant speed would be right here, and that was for 5 minutes. So that's true. Her speed was increasing longer than it was decreasing. All right, so we're going to make green be the increasing intervals. So we increase for 5 minutes. We increase for another 5 minutes. So we increased for 10 minutes. Now let's look at decreasing. So we decreased from 10 to 20, and then we decreased from 25 to 30. So 10 minutes and 5 minutes. So we decreased 15 minutes. So it cannot, that's false. So that's not true. Correct answer is B. Let's just check the other two. Teresa's speed decreased constant for the last 5 minutes. And Teresa's speed reached its maximum during the last 10 minutes. So both of those are correct. Moving on up to number 12. So let me get rid of this little stuff that's in our way. All right, so we have the height versus time for the bouncing ball. Height's on the left, time's on the bottom. Part of the experiment, the ball was dropped and allowed to bounce repeatedly off the ground until it came to rest. The graph above shows the relationship. So question is, after it was dropped, how many times was the ball at a height of 2 feet? So, you know, my line for 2 feet is right here. This is the line for 2 feet. So how many times was our ball at 2 feet? Well, it looks like it was there, there, and there. So correct answer here is C, 3. And number 13, I screwed up. Number 13, if you'll notice, is the same as 11. So that was a repeat that shouldn't have been on there. So we are all done with reading dated B.